we're going to talk about intervals on the real line and what an interval is. Let me construct here the real line. Okay. So this interval notation is extremely going to be important. Of course, everything we talk about here is important, but this is really imperative that we get this down. And we're talking about sets of numbers here. So if I chose a number on the real number line, let's say this location here, and we'll call our real number A, and we'll say that this is B. Now we're talking about all the points between A and B. If I want to include A and I want to include B, then I'm going to do this. I'm going to write it. Oh, I said I want to include them, don't I? Well, we write them with these brackets here, and this means that this set includes A and this set includes B. Um, let's say, for example, A happens to be 0 and B happens to be, let's say, 100. And so we're talking about a set of numbers between 0 and 100 and including 0 and 100. Sometimes we let these be solid dots, right, including. Sometimes they're open circles, which means that we don't include it. I've seen it both ways over the years. Let's look at some of the other permutations of this. We may have, for example, a set that we're going to say is from A to B. Now, these parentheses right here means that we don't include A and B. We don't include it. All right. Or we could say something like, now this set means that we include B, but we don't include A. Right? And we could say this. Right, this set means we include A here, but we don't include B, and it's all the stuff in between. So I might put the bracket here and open parentheses here, and it's all the numbers between A and B, every single point that's between A and B, but we don't include B. Now there's some set notation that goes along with this that you need to be familiar with. And let's take, for example, this set here. Now, sometimes this looks confusing, and this looks like an ordered pair, which we hadn't really talked about, but in the Cartesian plane. But this is just a set of numbers. Now, set notation. We're going to let x represent our real number, and sometimes there's a semicolon here, or sometimes it's just a straight line. I like to just write a big straight line right here. Okay, and the way we write this is it's the set of all x. It's the set of all x such that, and this line right here means such that x is greater than a and x is less than b. Now you see this is x is greater than a because it doesn't include a. If this was an equal sign here, then we would have to put a bracket right here. And x is less than b. And so this is called set builder's notation. And higher up in mathematics, this is kind of what we use. We use the set builder's notation, but for a more shorthand, right, we write this. Now, there's one other set, and let me just scribble out here the real number line. Okay, what if we had something like, we'll say this is 1, and we're talking about the set going from 1 to infinity, right? It's a set of all numbers that's to the right of 1, and of course I'm not including 1, right? So it's like an open dot or a parentheses here. Now you need to remember here that this is going to always be a parentheses that's on the outside of the infinity symbol, because what this says is we can never reach infinity. What if we had negative infinity to positive infinity? Now, negative infinity to positive infinity, well, that set is all of R. That set's going to end up being all of R. Let's look at this set here in set builder's notation. So set builder's notation would say this is the set of X such that X is going to be greater, right, than 1. It's the set of all X such that X is greater than 1. And if this were a bracket here, this would be greater than or equal to 1.